Okay, let's first find the first derivative to answer part A and B. Okay, quotient rule. Differentiate at the top, you get 1 times x squared plus 1 minus, leave the x alone, differentiate at the bottom, you get 2x squared. So x squared plus 1 minus 2x squared gives you 1. So if I combine these two, you get minus x squared. Okay. So note the x squared plus 1 is always greater than or equal to 1. Okay, because x squared is always positive. That means there's no way x squared plus 1, this is always positive by the way, square can be 0. So there's no critical numbers from the bottom. Okay, so for this to equal to 0, to get the critical numbers, it's only when 1 minus x squared, okay, is equal to 0. Okay, so if I multiply both sides by -1, you get x squared minus 1. So the critical numbers are plus and minus 1. Okay, so let me leave that there for now. Let's actually now ask the question, when is a derivative positive? That's the same thing as asking, when is this positive? That's the same thing as asking, when is a numerator positive? Because the denominator is always positive. So as long as the numerator is positive, the whole thing is positive. Okay, let me multiply both sides by -1. Okay, less than 0. Okay, so same thing as I did here. This is a parabola. Okay, so it's positive when that's negative, meaning right there, okay, when x belongs to -1 to 1, okay, -1 to 1, f at x is increasing. Okay, increasing. In other words, -infinity to -1, union 1 to infinity, f at x is decreasing. Okay, decreasing. Now I can figure out whether the local max and minimum from looking at this graph. For -1, right before -1, it's positive, so the graph is going up. Right after it's negative, it's going down. Okay. Oh, so actually, you know what? We have to do it backwards. Sorry about that. So let me start again. So we know at -1, right? So when you get to -1 from the left side, so here's -1. From the left side, it's decreasing. It's going down. It's going down. After -1, it's going up. So this is actually a local minimum. So f at -1 is a local minimum. Okay, let me plug it in. -1 squared plus 1 gives you -12. This is a local minimum. Okay, if you use the same reasoning, f at 1 is going to be local max. Okay, so it's exactly half. This is a local max. Okay. Now continuing from here, let's find the second derivative. Differentiate at the top, you get minus 2x, x squared plus 1 squared minus 1 minus x squared. Differentiate at the bottom, you get 2. Chained by that, all over x squared plus 1 squared is going to give us a power of 4. Okay, so you can divide the top and bottom by x squared plus 1, so that makes that go away, one of those go away, one of those go away, so you get 3. So we have this. Multiply those two, you get 4x. So you get minus 2x cubed minus 2x minus 4x plus 4x cubed. Okay. So combine those two and you get 2x cubed. Combine these two, you get minus 6x. Factor out 2x from the top and you get x squared minus 3. Okay, now if I want to know where it's concaving up, I gotta ask the question, when is the second derivative positive? Now from here, that's the same thing as asking, when is just the numerator positive? The denominator still, okay, still, it's always, oh sorry, it's power of 3 here. Right? Because of the x squared plus 1, it's always positive. So let's ask the question, when is this positive? But this is a polynomial. Okay, if we factor, it's a polynomial of degree 3 with roots at 0, minus root 3, and root 3. So when is that positive? Right there and right there. So that means when x belongs to right in that interval, it's concaving up. Okay, in this interval here, okay, in between, so from minus infinity to minus root 3, union 0 to root 3, it's concaving down. Okay, so the concavity changes at all 3 points. Therefore, inflection points are x equals plus minus root 3 as well as 0.